Okay, so good afternoon, everybody. My name is Laurent Menuhin. I'm working from France. I'm in the laser business since a long time now. I started in 1992 with Rofin Sina Group, specialized in the automotive industry at the beginning. Now I'm managing the sales for the south of Europe. This means Italy, Spain, Portugal, and Israel. So in Israel, I'm working with Anazoran, and together we push the huge laser portfolio from Coherent. I would like to discuss with you this afternoon about a product introduced on the market by Coherent in 2019 on the last Laser Munich show. It's a welding head. Can help to in specific configuration. This head has been developed by all the engineers in our labs, and yeah, again, this head can really improve some work. First of all, let's introduce my company just to give you an idea about who we are, only on few slides. Coherent, it's an American company. We are based in California, US. In Santa Clara, it's 5,200 people around. Yeah, this company started in 1966. We are all around the world again, and as I said before, the main acquisition in 2016 was the Rofin Sina Technology Group. It was really important for Coherent to acquire this company because Rofin was really specialized in material processing, and so now Coherent can offer a lot of lasers and machines for the laser business. Let's give you some information about our specific markets. So we are in the microelectronics, material processing. We are able also to sell specific components, and we are working on scientific research and government programs. Regarding the microelectronics, where we are really strong, especially with our excimer laser, it's to treat the screen for mobile phone and OLED TV. It's a huge business for Coherent. So material processing, as I said, it's mainly from the Rofin group. In this area, we are able to supply some laser, high power laser from 10 kilowatts. But we are also able to supply some laser with only few watts to do specific markings, to assume traceabilities on parts.
Laurent?
Yes.
Sorry for stopping you. You need to share your screen so everyone could see the slides.
Ah.
Okay.
Is it okay now?
Not yet.
Ah, I understand. Is it better now?
Yeah, it's great. Thank you.
Okay, perfect. Let's go. Sorry for that. I made a mistake. Yeah, so material processes, as I said, so it's from the automotive industry to different kind of industrial area. In the laser components business, we are able to supply different kind of laser sources or specific optical device. And we are also able to supply all the device to measure laser power or laser energy, for example, for lasers. We are involved in a lot of scientific applications with different governments. Yes, it works. So just to give you an idea about all the laser we are able to supply, so it's quite huge. It's a very, very wide laser portfolio, from standard laser, very standard laser, to specific products. We have more or less all the wavelengths, level of power, pulse width, beam profile you can expect from the laser business. It is also important that we provide not only lasers, but systems. Systems means machines. We are able to do machines, and also subsystems. So if you want to build your own machine, we are able to provide you laser plus some accessories around. Global organization, we are more or less all around the world, but in any case, in every country, you will find always the same structure: salespeople and service people. We are in the automotive industry, for example, so we need to provide support to all of these big groups. So in order to have a good response time, yeah, we have always service guys ready to be able to go to each customer to repair lasers in case of problem. Like in Israel, for example, in Israel, we have a team with more or less 10 people with sales and service. We produce in 27 countries, mainly in America and Europe, and a little bit in Asia. In order to be able to have a quick response time to our customer, we have also some depot repair. Depot repair, this means that we have some lasers ready to be used, or laser to be exchanged, and we have also spare parts. So if your laser is in trouble, we are able to call all of these depot repair and to have the parts in a very, very short time. To sell some laser, we need to help our customer, and we need to advise them about what we can do with our laser. And for this, we have some application center. We have some laboratories in America, in Europe, and in Asia with all the lasers, and we are able to support you regarding your assembly. We are able to advise you on what to do, and to give you the best configuration. As I said, if you look on the right side, we are able to provide some machines, simple machines to 3D printing machines, for example. But we are also able to focus only on the laser, from nanosecond laser to femto laser, for example, and also high power fiber laser for the automotive industry, for example. So now, this is the main topic of this discussion. I would like to give you some information about this new product, the Smart Weld Plus. It's an innovative head, and with this presentation, I would like to show you how it works. Coming back a little bit to the basic, give you some inputs about why we create this Smart Weld Plus around all the knowledge of our engineers. And of course, and it's probably the best for you, I would like to give you some examples about what you can do with this head. Of course, if we go back a little bit in the theory of laser welding, around the process you have a lot of parameters, and all of these parameters can be very, very different from one assembly to another one. As you have seen in the first slides, we have a very, very huge laser portfolio. So it's difficult to say, okay, for this application or for this type of assembly, we need to use, or we will use this laser. we need to check a little bit more, and we need to understand what could be the best configuration. As I said, we have some laser with different kind of wavelengths, so it could be infrared, but it could be also green, or sometimes it could be also UV laser. We can work in CW mode, continuous waves, or we can work also in pulse mode. The beam profile of a laser is also very, very important. So all of these parameters are, of course, important, but the idea is not to adapt your parts to the laser. It's really the opposite, and this is how we are working at Coherent. The idea is to have the possibility to adapt all our components to your product. So this is more or less the different assembly we can face on the field. Start from the left. We have the joint, but it could be also overlap joint. It could be fillet joint, or it could be edge joint. So this is more or less the configuration we can face. So if you look at this welding configuration, what is very important to define from the beginning, it's your assembly. I mean, we need to compare this kind of drawing to your assembly. So my small sketch are quite nice, but it's also theory. So it will be in any case necessary to adapt the parameters of a laser, or probably also to adapt your parts to be sure that we are really able to reach your target. If we look at the butt joint configuration, what you are looking for, it's the width of the weld. If you weld with very, very good condition, very, very perfect, if you don't have any gap, of course, it's not necessary to have a very, very wide seam. Yeah, it works. Same for the overlap. For the overlap, if your parts, it's a mechanical part, if it's a part inside an engine, for example, it will be very, very important to define what will be the length at the interface. This value is very, very important. I think in this case, for example, we don't need about the penetration. What is really, really important, it's the width at the interface. If you look at the picture on the left side, you can easily understand by, according to a specific welding configuration, we are able to have some very, very narrow seam, or it could be wider. The only difference could be the laser, the level of power from the laser. It could be also the speed, but mainly the spot size. If you have a very, very small spot size and a lot of power, it's easy to understand that the penetration will be in any case higher. If you have a big spot size with some power, of course you can imagine that the penetration will be lower, but the seam will be wider. But again, what is really important to understand, it's what is really necessary. If we go now on the right side for the edge joint configuration, it's the same. Two edge, according to the spot size we will put on the edge, we can create this ball, for example. It could be very narrow, or it could be wider, and at the end we can have this kind of ball. It's just for your information, this kind of pins are used today in the automotive industry for the electrical engine, for example. So it's two wires side by side, and the idea is to create the ball on top to do this, to do the link. Same for the edge joint. In this case, the penetration will be important. We don't need to be really, really wide, but in this case, the penetration looks very, very important. But again, all of these parameters, we can help you to define what will be the size of the seam, but we need to define exactly what you need. And according to your set of specification, we will be able to adapt the beam to this weld. Just again, to give you a little bit more understanding about the spot size, I put some pictures on the top. It's only a sketch, but on the top of the pictures, very narrow weld. We can easily imagine that it's a green focus beam, for example. And the blue, it's the wider seam. In all of these pictures, the power is exactly the same. The speed is exactly the same. The focal length, it's exactly the same. The only difference, it's the spot size. So you can easily imagine that according to your project, according to the length at the interface you need, if we don't do the right configuration in terms of focus on spot size, it will be not possible to work in good condition when the part will be welded. So the spot size is very, very important. Of course, all of this small sketch are close to theory. It is theory. But unfortunately, we have usually a mismatch between the theory and the reality. From the real parts, we can have some gap. We can have some different kind of materials also. We can have also some chamfers sometimes. So we need to compensate all of this gap with, again, the spot size. But it's not so easy, because if you increase too much the spot size, this will involve some other problems. You will increase the molten material. And if you have too much molten materials, you can put also some oxidation inside. You can create some porosity. The heat affected zone will be higher because you will put too much energy inside the part. So the heat will increase around the weld. So in this case, we need really to adapt and to find a solution. And just by increasing the spot size, it will be definitely not enough. Another thing to mention is when the spot is really too big, this generates a lot of splatter. And splatter is really, really a nightmare. When you have small balls all around your parts, and when it's, I don't know, it could be medical parts, or when it's for a specific area, it will be very, very difficult sometimes to clean the parts. So again, if we find a way to be able to weld in good condition and by not just increasing the spot size, it will be very, very helpful. And of course, this is what we try to do with the smart weld. We introduced this smart weld, but again, it's in terms of innovation, this head is really based on Oak knowledge. And Oak knowledge from the past is welding head, but with fixed optics, no scanner. in a lot of configuration, we are using some scanner from a different kind of supplier. We are not doing our scanner. But for this head, we decided a few years ago to mix a scanning head with a fixed optic. And what is really, really important with a classic fixed welding head, it's the possibility to keep the beam quality. And if you are able to keep the beam quality from the laser on your part, this will definitely help you to weld in good condition. This will increase definitely the quality of the weld. So this head is really a mixture between a classic head and a scanner. This head is very compact. And the main advantage is the possibility to generate only one spot size. And with this spot size, to be able to fulfill more or less all the configuration I show you, even the mismatch between the theory and the real parts. Coming back again to the theory, just to give you some explanation about how it works. To focus a laser beam, we have few possibilities. It could be like on the left with a parabolic mirror. Honestly, it was mainly used in the past with CO2 laser. Today, we are using lens. Lens, it's probably, probably 99% of what people are using today on industrial application. The scanning head on our SmartWeld Plus is placed just on top of the lens. So the mirrors to move the beam are just on top of the lens. So when I move my beam on top, this creates a very small deviation after the lens. It's not really big. It's not like a conventional scanning head with big field, working field. Here it's really only few millimeters, no more. And with this head, and I would like to focus on this calculation. I don't want to do mathematics this afternoon, but just to give you an idea about why we made this head. It's, if you look at this calculation, some parameters are completely fixed. The wavelengths, for example, the wavelength is fixed. The diameter of the lens, so we try to have the maximum, so it's more or less fixed too. The focal length is also fixed. P, as far as I know, it's the same since a long time. And the K factor. The K factor, it's probably the variable in this case, because the K factor is the beam quality. If you go through a lens or if you go through mirrors, you decrease this K factor. This means that from the end of a laser, at the exit of a laser and your parts, if you have multiple mirrors, you will decrease this K factor. And this K factor should be always between 0 and 1. If you are close to 1, this means that the K factor is very good. If you decrease the K factor, if you go to 0, you can easily understand by this calculation that the spot size will also increase. The spot size will be bigger. Because this head is coming from a standard fixed optic, we are really able to keep this K factor as good as from the laser. And usually we are using fiber laser for this kind of application. So if you are close to 1, and it's mostly the case with fiber laser in the range of up to 1 kilowatt. We are able to keep exactly the same key factor from the exit of a laser and the parts. So at the end, the quality of our focus beam is very, very good. Just to give you an idea about how we made the head, just like take my pointer. If you look at the head, it's quite easy. This is here. Oh, we have a camera on top, but this is the focal length here in this area. Collimation here in this area. And here, just in the middle, 2 mirrors for the scanner. So as you can see, this head is very, very compact. And only by moving these 2 mirrors here inside this small box, we are able to move the beam directly on the parts. So, as a first example, I would like to show you really a difference between what we are able to do with a standard YAG laser, for example, where the beam quality is really, really bad, and something absolutely similar, but realized with our smart weld. In some specific medical application, a lot of projects are qualified with this kind of YAG laser, and the picture on the left side is really a good example. So, and YAG laser are more or less obsolete. So we try to replace all of this laser with new technology, no maintenance, absolutely no consumable, but we are not able, it's difficult to reach exactly the same seam weld just because the beam quality from the fiber laser are much more better than the YAG laser. If you look at the picture on the left, it's a seam realized with the YAG laser. In this case, the spot size is around 800 micrometer. So it's a macro picture. And we did exactly the same with our smart weld. But in our cases, the spot size was only 30 microns. But because I have some scanner inside my head, I'm able to move the beam from the right to the left and so on, and to create a melting pool from all of this area in order to reach more or less the same cross section, to reach exactly the same penetration, but because I have a very, very small spot size, and because I'm going quite fast inside the material, the heat affected zone is not comparable. Much lower for the smart weld compared to the YAG laser. So in a lot of cases, it's an advantage. The also advantage, it's less power because I'm working with 30 micron, and because I'm going quite fast inside the material, I can use much less power. It's also an advantage, and this is also the reason why I'm able to decrease the heat affected zone. So in this case, because all of these parameters under control, I have a very, very stable weld. And because it's comparable, this weld is now qualified for this medical application because we are really, really close in terms of welding seams. The advantage to have some scanner inside the head is the possibility to create some specific patterns. The idea is not to go from right to left, we have also the possibility to create some very specific shape. And this definitely helps because all the materials react differently. When you weld aluminum, for example, or when you weld copper or stainless steel, sometimes it's better to have a very, very specific pattern. In this case, we need a little bit of imagination. Today in the head, 15 patterns stored. We have the possibility also, according to the pattern, we are also able to follow the contour, for example. So if you have a cross, for example, or also this Mickey Mouse shape, it's not on the picture, it will be later. You are also able to really track the seam and to put the right orientation on the pattern in order to be always in the same position compared to the edge. With this pattern, we are able to weld some very, very interesting welding configuration. We are very, very accurate. Look at the wire here, the wires here. In this case, usually people are doing spot size. In this case, and I just come back to the previous slide, we use this pattern, very specific pattern. The head is not moving, the wire are not moving, and we are really able to weld all of them without losing any power. It's definitely an advantage. So on the left, you have also an idea about what we realize with, it was the beam we saw on the last pictures. I have much more example to show you just after, but what I would like to show you, it's the different pattern and how fast. So of course here it's on low motion, but this is what you have. The beam is moving like this, and the part of the welding head is also moving in the same time. The spot size, what we see here, it's 30 micron. And we realize some specific shape. Again, to give you an idea about what we are able to do, this pattern is used to weld some specific stainless steel with some coating on top. It could be zinc, for example, only a few microns on zinc. Very helpful because with this two circle in front of the big one helps to vaporize the zinc. And you are really able to weld with this bigger ring. So it's just a tricky thing, but at the end, it works really, really perfectly. Okay, so now this is all my, my examples. Regarding the wires, and this is also the advantage of this head, I can use this head with continuous mode, but I can also use the laser in pulse mode, for example. It can help. It was the case here. We use a laser with 1.5 kilowatt peak power, maximum. As you can see, the wire diameter was around 200 microns. Again, I have more or less the same spot size for all my applications, so I'm around 30 microns. And I'm moving my beam on the wires only, and I'm really able to create a nice weld, protected by gas. So this is the reason why it's so shiny. But this is a good example about with one pattern, the possibility with, again, a very, very good beam quality and a very small spot size, 30 micron. This is what we are able to do. Difficult to see on this picture, so I hope you will trust me. It's a weld, but with 4 layers. Difficult to see here, but you have one layer here, another one here, here, and here. All of them 500 microns. And so, of course, in this case, you should imagine a clamping device to clamp all the layers, all the layers, to be sure that we will not have any gap. But this gives you an idea about what we are able to do. Again, 30 micron spot size. In this case, you can see here, we are using a pattern. It's like, it's not a snake, but it's a pattern with a lot of circles side by side. And the advantage of this is to help vaporization of the melting pool, and you can weld with absolutely no porosity inside the welding seam. This is really an advantage. Because I have a very, very small spot size, 30 micron, I'm also able to really manage the power on my melting pool, specifically when I have dissimilar materials. In this case, we have copper on one side, and on the other side, it's aluminum. And because I'm moving from one side to the other side, I'm really able to be very, very accurate. I'm able to spend maybe more time on one material and not on the other in order to create a correct melting pool and to not create any porosity or cracks. This is used mainly today in the automotive industry for batteries. The idea for this application was to be able to weld the battery in 5 seconds. And because of the speed of the head and the possibility to be quite stable in the seam, we achieve 1.5 seconds. And again, the laser was used in pulse mode. The advantage of this laser, the SF150P, is we can switch from continuous to pulse mode. So it's a very, very flexible laser. Brass. Brass is not easy to weld with laser. Very difficult. So again, in this case, specific pattern, it was a circle, but in the circle a very, very small sinusoid. And we are working in pulse mode 2. And at the end, we are able to have a very, very nice result. If you can see here on the screen, on the picture, it's quite smooth. And no cracks, no explosion. Still for the battery application, or battery market, here we are welding aluminum. Aluminum, sometimes it's easy because you have some specific series you can weld without any problem, but sometimes not. Aluminum series 6, for example, it's really a nightmare. You have a lot of cracks. In this case, it's a bush bar welding. So it's a 1 kilowatt fiber laser with a Smart Weld Plus. And the idea was really to create some, the part is not moving. We are welding all the layers. There is a little bit gap, as you can see, and this is also the reason why if you look at the cross section, you will find some porosities, but it's quite low. We minimize the number of pores. The cosmetic aspect of the weld is also not so bad. Aluminum is always difficult to weld, but because we manage the melting pool, we have something quite stable. And at the end, yeah, from a cosmetic aspect, it's quite nice. And what is also very important is no impact visible on the backside. Because of the heat transfer on this layer, sometimes you create some holes on the backside. Again, here, I'm really able to apply the correct level of power to be able to weld all of these layers. And we had absolutely no problem. The part was painted and absolutely no visible impact. Still some push bar. Again, in this case, we speak about copper to aluminum. You can see the weld, so difficult to react the seam, but you can see here it's quite deep, and the length is also quite interesting. Very low level of porosity. Same configuration. The average power was around 500 watts. And in all of this configuration, we are using fiber laser. Fiber laser with single mode laser only. I probably miss this information, but if we want to keep a very good beam quality, of course, it's important to have from the laser a good beam quality. And this is the reason why all of these lasers shown here in these examples are with single mode laser. Even this 1 kilowatt fiber laser is single mode laser. Again, a battery. The main advantage in this case, it's the part and the laser is not moving. So it's more or less the same weld as the previous slide. But in this case, because we have a very, very small but enough working field, 20 millimeter by 20 millimeter, we are able to weld this circle with absolutely no movement from the battery or from the welding head. And for each spot size here, we use a specific pattern in order to have a spot around 1 millimeter diameter. Again, this gives you an idea between the SmartWeld Plus with the standard optics from a welding head and a different kind of scanning head you can find on the market. Because with a standard scanning head, you decrease the beam quality and you are using some very big working area. You can see that the penetration is quite difficult to manage, or sometimes you have also a little bit angle from one weld to another weld. So with SmartWeld Plus, because every spot it's exactly the same side by side, you are really able to stabilize the penetration depth. Again, some battery. In this case, we speak about 2 millimeter aluminum to 1 millimeter steel. It's again a push bar. We are in the field of a scanning head of a SmartWeld Plus, so no necessity to move something. quite simple. The only thing to do is really to clamp the bar on the battery. But if you look again at the surface, and because it's a huge surface, at the end it's quite cosmetic. So this means that really we weld it with very stable parameters in order to have something very, very clean. If you are able to weld, it's quite close to do short modification on the head and to be able to cut. This is what we are also able to do with this head. At the end, we just need to change the welding nozzle with a cutting nozzle. Of course, the holes of the nozzle here is quite big. We speak about 1 millimeter. But with a 1 millimeter diameter hole, we are able to do some holes around 1 millimeter maximum. In this case, and I will show you, I hope if it works, the video just after. In this case, we speak about 0.8 millimeter thickness. The laser, it's 600 watts. The main advantage is we are able to blow some gas in the same times in the nozzle, and this is what we are able to do. So we are able to drill it. So let's have a look to the video. It was okay, huh? But it's yes. As you can see, the process is quite fast. So you can imagine, of course, it's easy to understand how fast we go with the head and the cross table. But if you look at the picture here, the white circle, it's the beam moving inside the nozzle. And at the end, we have very, very, very nice holes. If I just come back here, this gives you an idea. So this is perfect holes for a microphone, for a mobile, for example. As I said, all of these lasers are used, all of it, no. This Smart Weld Plus is used only with single mode laser. With coherent, you have the possibility to use some laser from 100 watts to 600 watts, 1 kilowatt also, 2 kilowatt in the next month. So we are on the way to increase the power also on this head. For the star fiber 150p, we can use also the laser in pulse mode and create 1.5 kilowatt peak power. As I said at the beginning, all of this laser can be put in machines, or we can supply only the laser and the head, but we are really able to supply some turnkey solutions. So you just have to be in front of a machine and load and unload your part. We have different application lab where we can do some tests for you, absolutely no problem. In different countries. So this is all the features from the head, as I said, single mode, pulse or CW mode. With the scanner, we are really able to control the power and the speed. So we are really able to stabilize the process. For dissimilar material, it's absolutely a good compromise to use this device. And we are, of course, able to create, we have 15 patterns inside the head, but as I said, we just need imagination. So we are able also to create others if you have a specific assembly, and it will be probably necessary to change a little bit the program, but it's very, very easy, and for this, the head is very, very flexible. And as I said, we are also able to drill micro holes quite fast with this technology. So this is all the example we showed together, we discussed together. I would like to say thank you. So this is the end of my presentation. So again, we are able to give you some advice about specific configuration, specific weld, and we are also able to do some specific tests if you want. I saw some question. We have few, but joint fit I can make. Yes, of course, yeah. Yes, you can weld by in CW mode, or you can weld also by spot welding. So I show a lot of cross section, so it's difficult to see the spot welding. So it would be better to have a look on top, but of course it's possible. So when I talk about a big spot size, what is the dimension of a big spot size? So usually when you weld, let's say small parts, I don't want to go with automotive gearbox, for example, but small, big spot size is around 100 to 150 microns. In this case, you are really able to weld in good condition, for example. If you have a very perfect assembly, if the edges are really, really nice, absolutely no problem. Again, the main difference between a standard configuration and the Smart Weld Plus, we are working with the Smart Weld Plus with a spot size of 30 micron. What about polymer and plastic? Absolutely not possible. The only way to work around polymer and plastic is to use CO2 laser. So it's another technology, and not possible to use this welding head with 10.6 micron right now. Do you need to push part one to the other? Yes, definitely yes. It's better. If you are in, probably not in every configuration. A little bit forge on both sides. This definitely help to create a good weld. What chill gas have you been using for welding the aluminum push bar? Honestly, I did not make the test personally. Honestly, I don't know. I don't want to say a mistake, but no, I don't know. It could be air. With air, it works. Again, it depends about what you want to see inside your weld. But with standard air, it works. Clean air, of course. So with nitrogen, it will work also. It depends. Sometimes for economical reason, we try to find the best gas in order to be sure that we, first of all, reach your target, and in order also to be not too expensive. No, how much power it is? 6 kilowatt? Definitely not. Maximum power for this head right now, it's 1 kilowatt and 2 kilowatt in our lab. Welding polymer too. Welding polymer could be. We have some specific device and specific laser to weld polymer. But why not? Honestly, we made this head to weld some metallic materials, but yeah, it could be possible. The only it will work if you take care about the polymer. In this case, you need to work a little bit on the polymer, but it will work. Yes, it's infrared laser, so it will work. Yes. Yeah. I think I have answered to all of us of a question. What about nitinol and nitinol to steel? Or to cut, absolutely no problem. To weld, nitinol, it's weldable. After that, it depends also about the thickness, about the power we will put on the parts. Definitely, we need to do some tries. I mean, a lot of parameters are important in this case, and difficult to answer like this. But again, if you have some tests, we will be happy to do it in our lab, and you will be sure to use exactly the right configuration after that. Is it okay?
Laurent, there is another question.
There is another question.
Yeah, what is the advantage compared to laser beam shaping?
It's a good question. It's cheaper because I'm using a standard laser and a welding head. Beam shaping, usually you are doing this beam shaping inside the laser. I'm thinking about a ring mod laser, for example. These lasers are really helpful, but we are doing this kind of laser. The arm laser, for example, in our laser portfolio, usually it's also with power from 4 kilowatt, 4 to 8 kilowatt. But in this level of power between 100 watts to 600 watts, you don't have so much laser who can do beam shaping, or you need specific optics at the end of a resonator. And from an economical point of view, I'm pretty sure that it's more expensive to do it. The Smart Weld Plus, it's really an industrial tool, and this helps to avoid the beam shaping. But at the end, we do more or less the same. It's quite comparable. Do you know how to prevent brightness of nitinol to stainless steel joint? Definitely, I will work on the gas. The shield gas will definitely change completely if you from one gas to another gas. But again, I don't know what you want exactly. Yeah, if you want to do some tests, we will be really happy. If you have a small set of specification, we will be happy to do some tests for you, definitely. I don't see any question now.
Any other questions?
I'm in time, not bad. Yeah. Again, we are available for any other questions. So the main advantage is regarding coherent, we are in Israel. We have a strong team, really able to answer you for any kind of questions.